Good morning, everybody, or good evening, wherever you're signing in from. Thanks for hopping on. We'll be getting started in just a few minutes. We'll start with some intros and a little bit of context setting and then get into the live stream. Okay. So as we kick off this live stream, we just want to thank you all again for hopping on and making time to talk to us and ask us questions about the NeMo Agent Toolkit. And today what we're going to be talking about is the toolkit and its integration with the Model Context Protocol. Uh, I'm Dhruv. I'm going to be your host today, and I'm joined by incredible solutions architects and engineers here at NVIDIA on the NeMo Agent Toolkit team, Svi, Matt, and Anuradha. And today, the four of us are going to be talking to you about the NeMo Agent Toolkit, its newest release, and its support for the Model Context Protocol. So feel free to ask us questions down in the chat, and we will be able to get to them as we go through the live stream. A couple of housekeeping items before we get started. We will be making reference to the NeMo Agent Toolkit as we go through the live stream today. For context, NeMo Agent Toolkit is a completely open source library for building, scaling, and optimizing agents for production that we built here at NVIDIA. It is open source, and you can find it on GitHub at this URL as we go through the live stream if you're interested in checking it out, cloning it, or contributing. If you have other questions that we may not be able to answer on the live stream or we possibly don't get to, you're always welcome to ask us questions on the NVIDIA Developer Discord. We have a section just for agents in the Agent Toolkit, so you're always welcome to ask questions there, and developers on the team or anybody else here at NVIDIA will be able to get to your questions on Discord. And if you don't feel comfortable or you don't want to go to Discord to ask us questions, you can also email us directly at developercommunity@nvidia.com. We look forward to hearing from you and listening to all your questions and providing answers. So with that context being said, let's kick it off. We'll start with a little bit of context setting about the NeMo Agent Toolkit and MCP in general. Feel free to please let us know where you're signing in from in the chat as you listen to the live stream, or if you have experience with MCP or your favorite MCP servers, put them in the chat and we'd love to see it. But with that being said, Matt, my first question is for you. We've been talking about the NeMo Agent Toolkit. I mentioned MCP. What is the NeMo Agent Toolkit at MCP? If you could provide a little bit of context to everybody listening in on what they are and how they communicate, that would be amazing.
Sure. So as you mentioned, right, NeMo Agent Toolkit is an open source library. It's super flexible and lightweight, and it's really designed to be a unifying library and runtime that allows you to kind of connect your agents with data sources and other tools, regardless of the framework that you might be implementing them in, right? So we really want to be an inclusive kind of platform that allows maybe a LangChain developer or a Llama Index developer or a LangGraph developer, and the list goes on to kind of be first-class citizens in this library, right? Do not make these developers coming in with opinions have to compromise, and be able to distribute these components with other developers, right? Just be very flexible there. And we want to sit on top of that with kind of a unified configuration interface. I want to say, hey, I want this agent with these tools, with these LLMs, with these specific configuration settings, and automatically bring up this heterogeneous system, right? So we want to be able to do that. And the way that we built the system allows us to, kind of behind a set of decorators, allows us to observe much of what's happening during runtime, regardless of the framework, through our observability system, right? So you're not spending time one-off instrumenting your system in order to get deep insight into how data is flowing through, right? And this allows us to build on top of that with things like a rich evaluation system, again, across all of these heterogeneous components. Answering the question, how good is my agent, my multi-agent system performing? How good are the outputs? Using standard techniques like LLM as a judge or RAGAS, but I think more generally, kind of extending the evaluation metric, maybe something that's a little bit more custom to your particular use case. And kind of building up further, right? Because we have a lot of these observability hooks and things, we can instrument the system. Not how good is the agent performing, but how efficient is the agent performing, right? Are there bottlenecks in my application that I need to resolve? Is there maybe a more efficient LLM I can use in order to give me to solve my latency budget, right? If you take that one step further, right, the next question that you're going to ask yourself is, what's my deployment footprint need to look like? If I'm expecting this number of concurrent users with this latency budget, how many GPUs do I need to think about? So when we think about targeting, enterprise agent deployments, this unifying library really lets us solve a lot of those additional questions that are going to be needing to be answered when you go from proof of concept to production. And again, kind of across that come as you are developer ecosystem. Right, so now let's get into MCP. So MCP is really great. So it's a great way to kind of put a black box around your agent and serve it up such that another MCP client can consume any tool that's hosted by that server, which is really great for decoupled applications. It's kind of in that serving, kind of along that serving dimension, right? You have this agent that you want to expose so other things can use it. Some people might expose a REST interface, maybe exposing the agent as through a WebSocket interface, but more and more commonly we want to expose these agents via MCP so that other members of the ecosystem can interact with it. So that's kind of like the USB for your agents. So how we're kind of plugging into this is providing that serving interface, right? Anything that you build with Toolkit can become an MCP server. We can also integrate with any other MCP server and tool and treat those as first-class citizens, right? Not every system is going to be built on NeMo Agent Toolkit. We should be able to work with the entire ecosystem of MCP servers and tools, and that's really the vision here. And I think more generally, right, the plugin system behind all this greatness lets us extend to future serving paradigms that may emerge maybe a year or two from now. And that plugin extension is supported by every one of these dimensions of support.
That's incredibly helpful, Matt. Thank you for walking me through that. One more question for you before we talk more deeper about the integration is, as developers are listening in to what we're talking about today, what are one or two things that you're hoping they can take away from this conversation and towards MCP or the toolkit?
Yeah, for me, I'm hoping that come as you are, right? Where there's developers across the world that have preference for frameworks, preference for no frameworks, right? Some agentic AI developers are programming directly in async IO, and that's great. I want all of those developers who want to play in the MCP ecosystem and take advantage of all of these benefits that you're going to need to solve to go to production to see themselves in this toolkit, right? I want this to enable them to be a first-class MCP server that you can expose to any MCP client within your enterprise.
Awesome, thank you. That was great and fantastic action items for our developers, right? That we can support with. So thank you, Matt. Anuradha, my next question's for you. We've talked about the toolkit. We've talked about what MCP is and how we enable it. I alluded to earlier on in our introduction that we have a new release supporting the MCP paradigm in the toolkit. So talk to us a little bit about these new features that have come in. What's the new release looking like, and how can developers expect to find support for MCP in the toolkit?
Yeah, definitely, Drew. So in the latest release, we have full bidirectional support for MCP, and Matt briefly touched upon it, how you could act as a client or a server. You can act as a client, you can set up any AI application, workflow, agentic or otherwise, and use tools, which could be just local tools, or it could be remote tools that are hosted by a different cluster as an MCP service. It's a completely seamless integration, and the application is not particularly aware of the fact that it's using a local or a remote tool. So that's the client aspect. And we've also added the server aspect where you could publish any tool as an MCP service. And this goes back again to what Matt said, build it once and use it in different ways, right? You want to build it in a way that's easiest for you to develop, finding bottlenecks using the profiling system, evaluating it for accuracy, observing deep observability capabilities that come with Nate. And then you want to publish it in different ways, in ways that your system wants it to be, which could be MCP today, it could be ATA, or completely extendable to any protocol in the future.
Oh, it's super interesting. I do have a follow-up as you were going through this, developing for extensibility versus the ability to serve it in different ways or use other tools. So if I was a developer on the toolkit, what would an MCP tool look like for me, or being served as an MCP look like for me? Would I have to develop specifically for MCP, or what does that interface look like? Great
question. You do not. Whether you're using it as a client or a server, you do not have to differentiate it for different protocols. You build the tool as just a tool that you want your agent to consume, and then you could publish it using Fast API or MCP. And you do not have to even know about it. It's as simple as just using a front end that's already available in the NeMo Agent Toolkit repository.
Super cool. Are there examples in the repository where folks can get started with MCP or agents in general? How hard is
Yes.
it for me?
Yeah, it's very easy to do. In fact, we do actually have an example where we show a simple calculator function in different ways of publishing it as using fast API or using MCP, and similarly having existing workflows consume locally instantiated tools or remote tools with MCP. The one interesting thing that I wanted to touch upon, Drew, is I've been seeing a lot of cool and compelling MCP servers being built by folks around us. And there are two different categories of tools. One is people are just building brand new tools. And Nate is a great way. You just take any process and you build a tool as effectively as you want and then publish it using MCP. I'm also seeing this new category of development where folks are taking existing systems, complete systems, applications, and adding an MCP front end to it, which is really amazing because now you can see how an existing product, a time-tested product, would work with an agentic thought process without having to fully rebuild it. So this is a very interesting new type of development that I'm seeing with MCP.
That is fascinating, and I wonder if anybody tuning in our audience has had experience with either one of those things. So we would love to hear from you as you're watching. Right? If you have favorite MCP servers, if you have a paradigm that you'd love to explore with MCP or agents in general, we'd love to hear about it, and we can talk about it. So thank you, Anuradha. That was incredibly helpful. So we've talked about examples, we've talked about the toolkit, we've talked about MCP. I think it would be really interesting if we could see an example as a live demo of perhaps an MCP with the NeMo Agent Toolkit. And that's what Zvi is here for today. And so welcome, Zvi. Thank you for making the time. Demos. I believe you have a demo for us about using the NeMo Agent Toolkit with MCP. So I will hand it off to you, and maybe you walk us through some diagrams and a live demo.
Thanks, Drew. And hi, everyone. My name is Zvi Lapp. I'm excited to share with you how NeMo Agent Toolkit works together with MCP to power enterprise AI agents. I'm going to share a little bit of a story and background from an experience that I had, and then we're going to dive into the code and to see how it works and works live with the NeMo Agent Toolkit. And then we'll give a quick recap just to summarize what we saw. So agents have many components, including memory, planning, and tools. This helps answer queries users have. So for example, what's the weather in New York today? This is a query where the model can't rely on what it learned during training. It needs the most current data to respond. Integrating this knowledge can be done with tool calls. So the agent creates a plan, performs the tool calls to answer the query effectively. And then if we have the data in the tool, then the agent can respond to the user's query as well. And in addition, if we had in memory my current location, for example, the agent could also handle the query of what's the weather in my current location today. So again, like if we have my current location stored in memory, and we can extrapolate and use that for the agent to extract more data and to enhance the data and the tool calling as well. So some of the challenges that we face in enterprise settings is that in air-gapped environments, there's a very hard constraint that all tool calls must be internally made within the network. That means that no external API calls or MCP tool calls could be made. All needs to be hosted on-premise within the air-gapped environment. And this is a limiting factor that we can't search and enable search, and that search is a very popular agent tool. So, but in the air-gapped environment, it's a little bit limited as a result of this constraint. So with MCP, and we can use an Elasticsearch server that enterprises can deploy, and it might already have deployed. And we can, even in air-gapped environments, enable the agent to perform search. And that way it can help meet the data security and privacy requirements that enterprises have. So what's nice about Elasticsearch, it's that it's scalable to millions of documents. It connects directly to existing knowledge bases and avoids heavyweight ingestion pipelines with only minimal pre-processing. So this makes it very able to search and interact with data that's fresh while keeping the information, the data is continuously updated and exposed to the agent as a result of the continuous updating that was happening already to the Elasticsearch document store. So NeMo Agent Toolkit makes MCP integration and serving very seamless. So using the official Elasticsearch MCP server from Docker Hub, that's something I will see in a moment, that how I pulled it in. So you can spin up a React agent that connects to an MCP server very quickly with the NeMo Agent Toolkit. And we'll see something very interesting, how the React agent can actually take the natural language query, translate it into Elasticsearch query, reason about the response, and return the results in natural language as well.
Zvi, I have a quick question for you, and this is coming in from our audience. You mentioned air gap. What does that mean to be in an air gap environment? What's the definition? What does that entail for enterprise deployments? We'd love a little bit of context there.
For sure, absolutely. So in very privacy adhering settings in enterprises, such as healthcare or banking systems or financial systems, data needs to be very contained and cannot leave the premise. That means also the deployment of the LLMs themselves, they need to be on premise and not with an external API LLM provider. And that's something that with NVIDIA we provide as well with our NIMs. But so back to the question, so air-gapped environments means that it's a very, very tight network and that no system within that's functioning, no software component can make any external API calls. So a lot of the times we have MCP servers that are hosted externally. So with NeMo Agent Toolkit, we were able to integrate a locally served MCP server in the air-gapped environment. I hope that answered the question.
Absolutely. Thanks, Zvi.
Okay, so it's demo time. Let's hop into some code.
In the meantime, Matt, I did have a question for you. What is a React agent and what's a workflow? We saw that in the previous diagram with the toolkit. What does that mean?
Yeah, sure. So a React agent is, it actually resembles how a lot of us think, right? You get a prompt, right? The React agent will think about what does this prompt mean? What do I need to do in order to respond to this? Oh, this is a question about weather. I need to invoke a tool. What tools do I have? Okay, I'm going to query some weather API within Virginia, which is where I live. Great, I have the response back. What does that now mean about my context, right? What does that now mean about how I've iterated through reasoning? Then loop through that. So that's generally what a React agent will do. You'll see that, versions of that pattern across other agent types. But yeah, that's a little bit, the layman's term as about what a React agent is.
Awesome. Thanks, Matt. I see we have another question from Steven. Anuradha, I'll let you take this one. So if Nate can run an air-gapped environment, does that mean we can also do evaluations locally?
Absolutely. You could do evaluation at the time of development just using inline evaluation, run the workflow, evaluate. You can also do the evaluation offline, but entirely locally using this air-gapped environment.
Sounds like it's incredibly flexible. Thanks, Anuradha. I appreciate that. Zvi, back over to you for the demo.
Awesome. Thanks, Drew. So what we have here, we have NeMo Agent Toolkit. I cloned it from the public GitHub repository. And I have a project that I opened. And what we have here is the config YAML file. This is where the entire workflow is actually organized and configured. And it's very convenient that it's all in one place as well. So let's go step by step and understand what the workflow contains. And then we'll actually run it and see the query and the responses as well. So first thing we have is the telemetry. And this is done with the Phoenix server. Let's just give it, let's load it up over here. So this is what the Phoenix server looks like. It's actually very convenient to track and to have the telemetry of all the queries that were done and to also see how the agent made the tool calls. And it's also, you could think of it as a single source of truth for all the queries that were made, and enables us to have one interpretability of all of the agent's tool calling vis-a-vis MCP, because that could be challenging sometimes to actually go about and see the entire flow of what was done. And also it allows us to have the latency and see the actual token usage. And Aranda referred to that earlier about being able to diagnose bottlenecks. That's where this comes into play a lot of times as well. So let's go back.
Can I ask a quick question about that? That's interesting. So Are you telling the developers that they don't have to do one-off instrumentation of their agent code? They just turn on observability with, what is this? Effectively 4 lines of configuration.
It's amazing. It really, it's all it took was 4 lines of config, a single command comes out of the box with the NeMo Agent Toolkit, and you have something that's essential to every LLM agent app that you want to be able to expose and to have that convenience of the NeMo Agent Toolkit. And I'll just also add that this is also particularly important in the enterprise setting also. And again, this is all done in the air-gapped on-premise. That way, all data is self-contained within your network. And to have that single source of truth is essential for any debugging and interpretability of the agent's behaviors as well. Okay, so yeah, like Matt was saying, all I needed to do was put 4 lines of config, and we have great functionality that's essential for every enterprise app.
Zvi, just another really quick question. We have a question from George in the chat about open source LLMs and which ones are recommended to work in an air-gapped environment. I recall you mentioning something about our NIMs. Is that a good fit here?
Absolutely. So that's a good segue. We were just about to get to that. And so yes, we have our NIM solution, which is NVIDIA Inference Microservice. And there we're hosting, you could go to the build.nvidia.com and see all the models that we have available. And what's nice and what's very convenient with NIM is that we have the NIM profiles and the engine files that are able to download. So all you need to do, you can take the NIM container, which is a Docker image for all purposes. You can pull the container and you can transfer that into the air-gapped environment with the engine file as well. Even more so, recently we released a universal NIM solution where we're able to take any Hugging Face model and actually expose that as a NIM. So if, let's say, you have a model that you found on Hugging Face that isn't in our NIM portal on build.nvidia.com, you can actually NIMify it as well. And I'll just add another anecdote of strengths of having NIM as well. It plays with LangChain, it plays with Llama Index, it plays with Haystack. We have supported bindings for all of them, all because all of the NIMs are one that actually dedicated libraries, but furthermore, they're all playing against the OpenAI spec as well. So that's in terms of the LLMs as well, and how to deploy them in the enterprise setting in air-gapped environments.
Awesome. Thank you, Zvi. Appreciate it. Back over to you to continue with the demo.
Perfect. So what we have now in the config, so here again too, what we want to do now is we want to define the functions, which are the tools that the agent will have exposed to it. So the first tool that we have is the current date time. And this is a native type that comes out of the box with the current date time. And again, this provides the agent for what's the date, essentially. A lot of the conveniences that NeMo Agent Toolkit provides is that it has these types pre-built. That way you don't have to actually come and implement this on your own. So it just comes out of the box, very convenient. The second tool, this is where we interface vis-a-vis the MCP tool wrapper that connects to Elasticsearch cluster. This is the weather search. Again, for this demo purposes, we're just continue with the weather example and see how that goes with how the agent will be able to interface with types of queries. And again, here what we have is a type that's native to NeMo Agent Toolkit, and it's called the MCP tool wrapper. And this again is the client that's going to be interacting with the MCP Elasticsearch server. So you could see down here, down at the bottom, I'll just make sure it's up and running also, Docker PS. So we have right now, we have a local officially released Docker container that's running of Elasticsearch. And also I have a running container from the official image of the MCP Elasticsearch as well. And this is exposing the Elasticsearch cluster. Again, the Elasticsearch cluster could be distributed to multi-nodes as well. And all we need is to have an MCP server that's exposing the actual Elasticsearch cluster. And then from the client, all we needed to do was to configure the URL that's listening on. Again, you can see over here, that's the actual binding of the port. And all we did was configure a single line. And now we have an agent that can interact with an MCP server. Again, like what Matt was saying, all it takes is a few lines of config, and you have something that's already an agent that can interact with an MCP server, which is not to take lightly at all. This is something that's very, very powerful. And again, what makes it so nice is that this is a native type within the NeMo Agent Toolkit. So the next configuration is that we just called the tool name, we call it search, because we're providing search over Elasticsearch. And then we have a description to provide the agent an understanding of what is the context of the type of search. And let's go into this a little bit closer and deeper. So we have what the description is that we have that it searches over the weather index in Elasticsearch for weather information. So the way Elasticsearch works is that there are many, many indices. And here specifically, we're having this tool be subcontained to the weather index explicitly to extract the weather information. Here also, what we're doing, you could see in the code over here, is that we always want to use the index weather. That's something that we're trying to prime the agent to make sure that it only does the weather index when it does the queries. And then we have also an example query, and this is to help the agent to understand what the type of queries that can be made and what is the actual query that can be done. You can think of it as a one-shot type of prompting that we give the agent in order to have an understanding of the ways the queries can be made to the index. And then we have just the available fields that are within the index to give a little bit more domain knowledge of this specific index. That's something that could be helpful when reasoning about how to answer queries. Okay, so that's the MCP tool. We discussed the LLM, how it's deployed with NIM. Here we defined the temperature to be 0 because we want the answers to be precise. And now this is where the magic happens, that all we need to do is define a workflow. And we described the type of the workflow. And here, this is the React agent. And here too, this came out of the box as a first-class citizen of the NeMo Agent Toolkit. That's what Matt was referring to also. That's great to have, that you don't have to reinvent the wheel and custom create the application on your own. This is a pretty standard. React agent is pretty standard. So we have that also as a first-class citizen. And then we bind the React agent to the tools. And this is where we inject the tool calling capabilities. And we just pass the arguments of what we defined earlier in the configuration file. So we have the current date time, the weather search, and then we have the LLM that's going to be integrated as well. Here we have verbose for debuggability purposes. And then we have the retry that we have set true and the number of times that we want to retry. So that was the configuration YAML. Drew, any questions before we do the actual live query?
I think this makes a ton of sense. So I would imagine, if there was another MCP that you wanted to use instead of weather, you would just also make that an MCP tool wrapper type. Is that right?
Exactly. And that's what's so nice about the MCP, that it's a standard protocol and we support that out of the box.
Okay, thank you.
Perfect. So again, we saw that we did a Docker PS, we have the MCP server up and running. Here we have the Phoenix telemetry server that's up and running. And now let's hit the query up. So now we have, this is the command line, the CLI that comes out of the box with NAT, NeMo Agent Toolkit. And now we're going to be running the query. And this, what we have to do first, we have to say NAT run, because we're running a single query right now. And then we're going to pass in the actual configuration of this workflow as an argument. And then we're going to pass the example query, what is the weather in New York today? So let's give it a run. So now what we're going to see a few things happen. We're going to see that Phoenix server telemetry is going to be integrated and running. And then we're going to also see that the connectivity of the MCP server, that this CLI command is actually interfacing the MCP server correctly as well. We're going to see that up and running. So we see that it's starting, right? Nice. We have the Phoenix server directory. Again, that's hosted locally. You can configure that, I'm assuming, also. And then we have the Phoenix inference. It's initialized. We're up and running. And now it's going into the MCP actual configuration as well. Great. So we have here the configured to use tool search MCP. So that was nice that we see also that the URL is our local URL. Very important to make sure that, again, in the air-gapped environments and the enterprises, we want all the API calls to be on-premise and within the network. So now we can just also do a quick rundown on the actual workflow itself. So we have a React agent workflow type. Again, this makes sense. This is our config, 2 functions, and 1 LLM. And the rest are 0 because we didn't have any other necessary configurations as well. So now let's dive in here and actually see how the React agent is handling the query. So here we have what I mentioned before, is that we have the natural language query that comes in. What is the weather in New York today? That's the query that we passed in from the CLI. And then the agent is thinking, to answer this question, I need to search for the current weather in New York. I can use the weather search tool to do this. Great, so it understood that it has the tools to answer this query. And then we see the actual formulating of how it's going to actually perform the call and with what input. And this is great, again, for interpretability to understand what's going on. Later, we'll see also that this is stored in Phoenix. So then we see that the index, it's using the right index, it's passing the right query. What's very interesting over here, and this is a very cool aspect of the React agent and the LLM as well, is that we see that it provided a size of 1 and sorting according to date in descending order. This is shows, first of all, what does this actual aspect of the query do in essence? It means to return 1 document from the Elasticsearch server. And furthermore, it's also saying to do this in descending order, meaning to take the latest document that's in the Elasticsearch document store. And that makes sense because we want to have to answer the question of today, the most recent. That's something that's very...
Yeah. I'm so sorry to interrupt you. If you want to finish your thought, we had a question from the audience, but so Antonia said, our entire app just baked in a single config file, which is really, really powerful. So we love to see that. We did have another question from Keshav in the chat about what Elasticsearch is. Could you give us maybe a little Spark Notes, 1 sentence? What does Elasticsearch do?
For sure. So Elasticsearch enables enterprises to do searching over their documents. And you have what's the primitives there include what's called an index. And you can think of it as just storing, often a lot of times, like the different types of use cases that it happens to support is that, let's say you have millions of documents. It could be a catalog of different products, of different records. And what is it? It's a document store that is indexable, that enables search. And that's what's so nice over here. You could think of it of doing just a normal search with a type of query that's very, very, very distributed over many nodes. Elasticsearch is a solution that's can be served over multiple nodes. And that's what makes it so useful for enterprise settings. And then you can just do simple queries over the documents themselves as well. So just to recap in short, Elasticsearch enables search over documents that are indexed in a document store. I hope that answered the question.
Absolutely. Yes. Thank you.
Okay. So back to the query, and this is what's something that's so novel and amazing with LLMs, is that the fact that the agent and the LLM knew to add this extra piece to the query in order to answer that question effectively. And this isn't something that we needed to prompt. Meaning, if you look back in the query that we prompted, I didn't add anything that's related to size or sorting, but the agent knew already that it needed to perform the retrieving of 1 document and the latest document. And furthermore, it knew how to do that in the proper Elasticsearch syntax as well. Because apparently, since the LLM was trained on a massive corpus of data, so it had an inductive bias and understanding of what a correct Elasticsearch query actually looks like, which is very cool. Okay, so then we have the actual tool that's being called. Again, we saw the input before, and this is the response. And we see that it's actually getting the latest date as well from the cluster too. So that's something that's very nice. It gives all the documents that are related to New York again. So it was the initial query that we made with New York, and it gives all the weather information as well. But again, this is format here. So just to give a short recap, we went from natural language to Elasticsearch syntax query to an Elasticsearch response. And now what we're going to see a natural language response, meaning the agent understands that it needs to reason about the response from the MCP tool call and give the answer in natural language. And then it provides the actual natural language response that's coherent and in natural language that any person can understand when performing the user queries. So that recaps how to use the nat run CLI. Now, for the next part, what we're going to do something even cooler. We're going to actually expose this entire workflow as an MCP server itself as well. So just to give context on the architecture here, we had an MCP server that's facing the Elasticsearch server, and then we're having another MCP server that's the front face of the actual React agent as well. That way, any third-party client that knows how to do MCP client calls to an MCP server can actually do that. So let's get that up and running. Okay, so let's see what is the command that just ran. So again, we're using the NeMo Agent Toolkit MCP config file. We're passing that as an argument. And here again, this is what's so cool about the NeMo Agent Toolkit, is that this comes out of the box, that we want to expose our agent as an MCP server as well. We're able to do that out of the box with NeMo Agent Toolkit.
So did you need to do any changes to the configuration file to publish this as MCP tools?
Zero. I didn't need to make any changes. The same query that I made is now able to be facing the MCP clients as well. So zero changes to the config, same config file.
So if our developers V had an agent that was also working with an MCP tool and it wanted to talk to your agent as an MCP tool, would this help enable that?
Absolutely. And we're going to see that in a moment. We're going to see how we're going to have the cursor agent interact with our MCP React weather agent application. And we'll see how to configure that exactly in a moment. So as you can see, we have the server. Any questions before we continue? Or okay, awesome. So we're going to have, so right now we have the MCP server that's up and running, that's wrapping our React agent. Now, just to make sure that everything is up and correct and running, what we're going to do, we're just going to do a nat info MCP, just to see which NeMo Agent Toolkit agents are actually being exposed, what tools are being exposed vis-a-vis the MCP protocol. And we see we have our React agent that's exposed and ready to receive queries as well. So now for the actual query calls themselves. So again, we're going to make client MCP calls to our MCP server hosting our React agent. So we're going to go to cursor. We're going to just go into, this is what you would do if you do for the first time. You go in and you configure it to be to our MCP server that's being hosted. You could see that the actual ports, that they're correct. And we have the actual URL here as well. Again, the whole beauty of this is it all can be done on premise without any external API calls as well. So we have this configured. Now I'm just going to do a quick toggle on and off. And now we see that it's actually connected, and we see that it's able to process now connections. So we see that it's green light. Let's give it a run now.
While this runs, Anuradha, a question for you would be, so is, without NatMCP being the command line, Is it complex to get an MCP server up and running if the developer had an agent or something else that they wanted to expose to an agent or another system?
Right. Yes, it does require code changes. You have to integrate your tool with fast MCP and then publish it. This is a no code, in fact, a no config change way to just publish any tool with any front end, which is right now MCP, and could be any extensible protocol in the future.
Awesome. Thank you. Back to you, Svi.
So we have the client ready to make the MCP call. Just notice we're going to see it hit over here in a second. We're going to hit run tool, and we see already that the MCP server received the query. And again, it's doing the same type of answering the query that we saw before. And then we see the results in the client as well. And we see that it's actually just to see the final answer. Again, it's coherent, it makes sense. And that was really a very cool way that we were able to interface MCP server that's hosted locally again, and with the NeMo Agent Toolkit out of the box, again, with simple configuration files. Now to the Phoenix server.
Really quick, sorry to interrupt you again. Did have a question for Matt as you go through this as well as you pull up Phoenix is, can Nate, the toolkit and MCP support in some combination also enable things like multi-agent systems, for example, deep research applications? Is that something this could scale to?
Absolutely, absolutely. We actually have an example of something like that running on our IQ Blueprint. I don't know if we can post a link to that perhaps in the chat as well. But I think in general, right, the ability to configure a multi-agent system entirely from YAML is very possible. You know, some of those agents could be implemented by you in your MCP black box. Some of them may be implemented by somebody else, maybe not in NeMo Agent Toolkit, wrapped in their own MCP server, right? So I think it's super flexible, and that's very much part of the design philosophy.
Awesome, thank you.
All right, so now we have the telemetry. And again, we see that this was done the latest time, that it's corresponding to the time. And we see this is the actual queries that were made. We see the amount of tokens that it took, and the actual process that was done of the same exact logs that we had in the terminal. We actually have them captured with the telemetry, and we can go step by step and understand the exact way the agent was able to reason about and get to the actual solution and to respond. You can see it end to end into the intermediate steps as well. This was very cool to see also, and it was very exciting to see this type of capability. And again, like I mentioned, this can be stored for many months in your storage and have this for auditing purposes. Many times for enterprise settings, you want to have that auditing ability in order to see that and reason about also, and have interpretability into how the agent was able to achieve its answers to the queries themselves as well. So just to give a recap. So yeah, Drew, if you have a question?
I don't, I'm sorry. Didn't mean to go off.
So just to give a recap of what we saw. So we saw how the MCP server can be hosted and interface vis-a-vis Elasticsearch MCP, and it supports deployment in air-gapped environments, helping meet enterprise requirements for data security and privacy. Elasticsearch is a very scalable, distributed document store, so that enables us to access millions of documents and connect to already existing internal knowledge bases if they're already hosted, and avoids lengthy ingestion pipelines with minimal pre-processing of data. And we were able to really quickly interact and search over the indexed documents. And what was nice is that we have the freshness, meaning the weather data is constantly being updated. That's just for the example purposes. But the agent is always continuously updated the moment the actual document store is also updated as well. Again, NeMo Agent Toolkit enabled us to connect very easily to MCP, to the actual MCP server that was the official Docker Hub implementation of the MCP server for Elasticsearch. And we were also able to get a server of the React agent as the MCP server very easily as well. And also what was very nice, we were able to see how the React agent could translate the natural language query, translate it to Elasticsearch requests, and actually reason about the requests themselves. That was thanks to the React agent's capabilities and with the inductive bias that the LLM has and understands different LLMs, the different Elasticsearch query capabilities. And then we had the telemetry, which enabled us to do interpretability and the speed of the queries, the different tools that were called. This is especially important in enterprise settings. And what was also nice, there was a question about multi-agents. So this type of framework could be easily extendable to multi-agents with the React agents over specific indices. Imagine that within the Elasticsearch, you have many, many indices. Each one of them could be mapped to a single React agent. And we could also add more than one index to a single React agent as well to have more than one domain knowledge exposed as a tool to the React agent. And all it takes is just to modify the config YAML as well. You could even probably think and do that programmatically, maybe with an agent or maybe with Cursor also, where we just have enable Cursor to do an MCP search tool call to see what the indices are available and actually do type of agentic programming to the config YAML file and actually extend it to be multi-agent as well. And it's very fast to spin up also, which is very cool. So NeMo, what was also, I think, particularly amazing is, I don't know if you, throughout the demo, we didn't actually see any Python code. All this came out of the box with the NeMo Agent Toolkit's plugins. Obviously, you can, if you want to configure into and implement your own type of agent as well with LangGraph, LangChain, Llama Index, Haystack. It's obviously able to do that as well and plug that in. But what's nice is also comes out with very, very state-of-the-art agent capabilities out of the box. It's very easily extendable with the configuration YAML file.
That's
then
awesome.
also, yeah, I think that was particularly amazing. And that's what we saw here, that I was able to get this type of application very quickly up and running.
Yeah.
So just, yeah.
Go ahead, sorry.
So then we saw that we were able to test this with Cursor. And just overall, the NeMo Agent Toolkit accelerated the speed of deploying the agent and getting a working solution with best practices out of the box. And that was something that was very cool.
That was very cool. Thank you for walking us through that demo and showing us the art of the possible with MCP and the NeMo Agent Toolkit. I saw a couple questions in the chat about when will NeMo Agent Toolkit support a few features such as authorization for MCP or streamable HTTP support. I think that's a great segue for us to talk through, now that we've seen what exists, talk through what's coming next and what the roadmap looks like. So Anuradha, I'll give you that question. What does a future for NeMo Agent Toolkit and MCP look like? What's the roadmap there?
Security, security, security. So top of mind is security through. That's definitely something that's important, both for onboarding as well as for the enterprise type POC to production that you were earlier referring to. And when it comes to security, we are looking at it both ways. We are looking at protecting the server, the service that's running your tools, as well as the client. Right, MCP authentication goes one way, protecting the service, but we also want to protect the client because we want to have a solid, easy developer experience where you could just onboard any new service you want. There are a lot of cool, compelling servers like we talked about, which is amazing. And we want to make it easy and safe for you to onboard it and securely use it later in production. In addition to that, we are trying to improve the user experience. So I'm very interested in finding out about the new tools and MCP servers that folks are developing or using. We are going to create an example repository where you can contribute those tools and we can collaborate with you on that. And we can use that as a way to improve the user experience as well.
That's incredibly exciting, and yeah, we do look forward to collaborating with the community. NeMo Agent Toolkit is completely open source. We welcome contributions to the toolkit. So if you have feature requests, make an issue, and if you have an idea that you want to contribute, make a pull request, and we will get to it. So with that, I wanted to thank all of you, Matt, Anuradha, SV, for your time, for your expertise, and for walking us through this today. I want to thank the audience for attending and for all your questions and the interaction. I think this is an incredible session. And yes, if you have questions that we didn't get to or you think of something after the live stream, feel free to ask us in Discord or email us and we will get to them. So with that, I think we can wrap up. Thank you all for your time again and have a wonderful day or evening wherever you are.
Thanks so much.
Thank you.